Hello, this is the fourth video in the series about how to build an indicator. In the first three videos, we built and tested a MACD indicator. In this video, we will build a plotter to create the graphical representation of the data over the charts. Let's get on with it. I'll add a plotter, label it, and customize the configuration. Now I'll do the same with the plotter module. The parameter icon refers to the icon used on the layer manager to visually indicate what type of indicator the layer represents. I'll choose histogram. You may choose anything you like and even create your own icons. Please find the details in the documentation. The most important underlying concept in building a plotter is that of points and their relationship with the vertices in the polygons that make up the graphics. I'll briefly explain, and if you need any clarification, please refer to the docs. The core idea of a plotter is the identification of specific points in the chart that describe the data points you wish to render on screen. The charts are two-dimensional coordinate systems. The x-axis represents time and the y-axis represents the rate. So, to define a point, we will need to specify a value for the x-axis and a value for the y-axis of each point. What points? Well, the ones we wish to draw over the charts. In the case of the MACD indicator, we will want to represent the MACD line, the signal line, and the histogram. The second most important concept is that the plotter produces a graphic representation for each record in the dataset and for the period of time represented by the record. This means that the polygons you define to produce drawings must be defined within the span of time represented by one record. For example, if you wish to draw a line, let's say a moving average, you will need to define 2 points. The first is the rate of the moving average at the time the candle opens, and the second is the rate at the time the candle closes. This will all be clearer when we make the definitions, so let's start with the line. The first point will be line begin. And in the formula, the value for the x-axis is record begin. Begin, of course, is the datetime in which the record starts, as we previously defined it when doing the record definition of the indicator. The value for the y-axis is record previous line. Line, of course, is the name of the record as we defined it in earlier videos. Now, why do we need to use the previous property? Well, bear in mind we are storing a single value for each of the properties in our indicator, and that value corresponds to the closing price. To draw a line, we need at least 2 points, right? Well, that is why we use the value of the line at the closing of the previous record as the first point in the line. Now, we'll call the second point line end. For the x value, we'll use record end, so that we use the datetime of the closing of the candle. And for the y value, we'll use record line. That's it. We have 2 points defined, and later we will use them to draw the MACD line. So I will do virtually the same thing for the signal, following the same logic. Now, how do we draw the histogram? The histogram consists of vertical lines or bars starting at the 0 value and either going up with positive values or down with negative values. The right thing would be to draw it in the middle of the candle in terms of daytime. So, for the first point in the line that represents the histogram, we will do the following. For the x-axis, we will use the difference between the closing daytime and the opening daytime divided by 2 plus the opening daytime. That should result in a point in time in the middle of the candle. So x equals record end minus record begin divided by 2 plus record begin. For the y-axis, we will simply set it to 0. We'll use the same daytime trick for the x-axis of the second point, but the y-axis will be record histogram. To make the histogram easier to read, we should probably add a horizontal line at the 0 level. So let's create a couple more points, setting the y value at 0 and the x values to record begin and record end respectively. Great, all points have been defined. Now we'll use those points to define polygons, and it's those polygons that will be drawn by the plotter. One thing to consider before we start: the order in which polygons are defined around the shapes node is the order in which they will be rendered on screen. This may be important in case some of the polygons intersect with each other. If that happens, the second polygon in the definition is drawn on top of the first, so we probably want to draw the 0 line first. To do that, we will add a second vertex to the polygon. We'll take the first one and establish a reference with the 0 begin point. And the second vertex will reference the 0 end point. That is the geometric definition of our polygon. That is, the polygon is mathematically defined by those two vertices. Now we will decide how we wish this polygon to be treated graphically. First of all, if this is a line, we will use the polygon border definition, and we may delete the polygon body node. The definition of the style is done at the level of the node's configuration. Let's refer to the docs to get the appropriate template, as there is a template for the body definition and a different one for the border definition. For the default section of the config, I'll use 0.5 for opacity and 0.5 for the line width. It will be a solid line, so I'll leave the line dash at 0, 0. For the palette color, let's find something that won't draw too much attention, like this gray for instance. At the mouse position section of the config defines the style to be applied to the active candle, that is, the candle that is being highlighted by the mouse pointer. I'll use 1 for opacity and 0.5 for line width. The color, I will leave it as is by default. Now I will do the setup for the histogram and stop to show you an interesting feature, the style condition. Okay, so I'm setting the histogram palette color to green. However, for optimal visual communication, it would be great if the histogram was red for negative values. That is, when the value is below the 0 line. To do that, I will add a style condition. The condition is quite simple. Record histogram is lower than 0. And for the style, we need to get the template that is used in style conditions, as it's slightly different to the default style. The difference lies in that when defining a conditional style, you may no longer define the at mouse position setting. That setting is defined only once. So I'll set the same parameters of opacity and line width, but change the palette color to rust red. Okay, for the MACD line and the signal line, the setup is virtually the same as for the zero line. I'll get on with those. Great, we're almost done. Let's set up the panel with the numerical value for each property and we'll be ready to test the plotter. As usual, I label the node and customize the configuration. We will need 2 more panel data nodes. And then it's all about labeling the node and setting up the formula. That's it. We're done. Now, let's set up the infrastructure so that we can see the results over the charts. First thing is to establish a reference from the product definition node to the plotter module node. This reference is what tells the system what plotter deals with the data of each product. Now, let's go to the charting space hierarchy and set up a new timeline chart for this indicator. The MACD indicator requires a rate scale of its own. That's why it needs to be in a separate timeline chart. If you're not proficient with timeline charts and scales, please do read those pages in the documentation. Now we need to go to the network hierarchy. We have to set up a data product under the session independent data branch of the data storage section. The data product must reference the indicator's product definition. And finally, we will establish a reference from the layer in the timeline chart to the data product we just created. This reference is what tells the layer which data product it should work with. And that's it. Now we can go to the charts, locate the timeline chart, and turn on the layer. Awesome! We can finally visualize the MACD indicator over the charts. So all you need to do now is just play around with the scales and make it fit your particular needs. It may happen that when you turn the layer on, nothing happens. In such a case, if you're positive that the data mining task has finished calculating and that the files look okay, then the troubleshooting is based mostly on the browser's console. For instance, let's say you forgot to reference the plotter module from the indicator's product definition. I'll remove the reference to simulate that situation. And always remember you must refresh the page for changes in the plotter to be enacted on the charts. Let's see what happens. The timeline chart seems to be empty. Let's check the browser's console. That's it. Could not start plotter because product definition MACD does not have a reference. Quite clear, right? Remember, when something goes wrong on the charts, the browser's console is your friend. And that's all, folks. You just completed the series on building indicators. Congratulations! Building indicators will greatly help you understand how SuperAlgos works under the hood, and will set you a step closer to becoming knowledgeable enough to contribute to the core system's code. And remember, contributing indicators to the project is a great way of giving back and is greatly appreciated by the community. Thanks for watching, and if you wish to be the first to learn about new video tutorials, subscribe to the channel if you haven't yet.